Afternoon, friends. Now, the concept of surface tension. So, it is defined as the tensile force acting on the surface of liquid in contact with the gas or on the surface between the two immiscible liquids. Now, if you see the figure, now we have here water. The water is having contact with the air above. So, now I have a thin membrane here formed, that is here the free surface of water. So the water molecules are forming a chain here, so that a thin membrane of water is formed here, so that thin membrane is acting as the protecting layer, so that it is not entering any foreign matter to enter inside the liquid or allowing the water molecules to escape into the atmosphere. So the reason of uh, you can give when you touch your free surface of water with the sharp edged nail, so you will feel that thin protective layer is formed on the free surface of water. And even if a lighter substance like a leaf from the tree is falling on the free surface of water, so that is not allowed to penetrate inside the water, so that is because of surface tension here. So the magnitude of this surface tension force is per unit length of the free surface, so it is expressed as Newton per meter. So that free surface tension is expressed denoted by Greek letter sigma. So in MKS units, so it is expressed as kg force per meter, and in SI units it is expressed as Newton per meter. So that is surface tension. Now we have small derivations on surface tension in case of liquid droplet. So consider a small droplet of liquid of radius r. So on the entire surface of the droplet, the tensile force due to surface tension is acting. Let sigma is the surface tension of the liquid, P is the pressure intensity inside the droplet, D is the diameter of the droplet. So you can see the droplet here. Imagine that I am going to cut this droplet into two equal parts. So here on the surface of the water droplet, so that surface tension force is acting. So that is sigma. So that is the pressure force acting on this area. So that is the circular area is now small p, so that is the pressure force. So the area is considered as pi d square by 4. So now the pressure is equal to force by area. So force is now pressure into area. So pressure is P and area is pi d square by 4. Similarly, if you take the surface tension, this surface tensile force is now surface tension, that is sigma acting on the circumference. So that is surface tension is equal to force by area. So force is equal to surface tension into area. Surface tension is sigma and area is this circumference. So that is pi into d. So that is sigma into pi d. So surface tension is equal to force by area. So force is surface tension into this circumferential area. So sigma into pi d. So for equilibrium, we are equating the pressure force and that surface tension force. So P into pi d square by 4 is equal to sigma into pi into d. So simplifying, we are getting this pressure as 4 sigma by d. So this equation shows that with the decrease of the diameter d, so of the droplet, so the pressure intensity inside the droplet increases because P is inversely proportional to D. So that is the case of your water droplet, the pressure intensity equation. Now we have the hollow bubble. If you take the case of the soap bubble, sorry, Yeah, if you take the case of the soap bubble, so here uh, uh, the water droplet is having some thickness, but the soap bubble is very thin, so we don't have any differentiation between my inner area and the outer area because it is very thin. So both our inner surface and the outer surface are the same. So here the hollow bubble, if you take as examples the soap bubble in the air, so as the two surfaces, both the surfaces are having in contact with the air, so the two surfaces are subjected to surface tension. But if you take the example of your water droplet, so only the outer area is subjected to the surface tension because it is having some thickness inside. Our inner area of the water droplet is different from the outer area. But in the case of soap bubble, both the areas are same. So both the inner surface and outer surface are subjected to surface tension. So we have sigma into pi d. So what we have in the case of water droplet here, so that is sigma into pi d. But in the case of water droplet, it is only the outer circumference is subjected to the surface tension. Now in case of soap bubble, both the inner and outer surfaces are subjected to the surface tension which is exposed to the air. So that is multiplied by 2 here, so that is equated to the pressure force P into pi d square by 4. Simplifying, we are getting P is equal to 8 sigma by d. So that is the case of surface tension in hollow bubble. Now we have the surface tension on a liquid jet. Assuming you are opening the tap, from the tap, so the liquid, so the water is coming out. Suppose if you cut, imagine that you are going to cut that water column. So taking that portion of the water column cut here, then again you are going, imagine that you are going to cut this water column into two equal halves, like the liquid jet is having the diameter d and the length L. So P is the pressure intensity inside the liquid jet above the outside pressure. So if you recall your pressure, so at any point we have the pressure which is above the atmospheric pressure or below the atmospheric pressure. So this P is the pressure intensity inside the liquid with respect to the outside pressure. Sigma is the surface tension. Now the force due to the pressure inside the liquid jet. So that liquid jet so is having the length L and the diameter D here. So this pressure is acting on this liquid jet having the length L and the diameter D. Considering this as the rectangular area now. So area of the jet is now L into D and the pressure acting on this rectangular area is P into L into D. Now force due to the surface tension, the surface tension is acting only on the periphery now. So this is having the length L and this is also having the length L. So it is now 2 into L. It is acting only on this edge of the water column, not on the width of the water column. So it is now the area is 2 into L, L plus L. So that is 2L into surface tension sigma. So equating the pressure force and the surface tension force, we have P is equal to sigma into